Okay guys, so now I'm going to walk you through the 5 different types of chemical reactions. You have to be able to understand in chemistry that when you are mixing stuff together, you have to know, one, what you're going to produce. If you're trying to break a compound down, you need to be able to tell what you're going to produce when you break it down. So the types of reactions are important to understand how the elements are going to actually interact with each other. Will they react? Will they do nothing? And what will I make after the reaction is over? Okay? So you have to be able to recognize the type of reaction you're dealing with by sight. It's nothing that you memorize. You can't memorize every synthesis reaction. You can't memorize every decomposition reaction. What you can do is look at a general formula, okay, a general idea of what's happening in the reaction. So the synthesis reaction is the first type. The word synthesis just means to synthesize, which means to put together. So this is a definition, and you may be asked a question about this. What type of reaction is a synthesis reaction? Well, it's one where you have 2 or more elements and they are forming that's a very important word, a new substance. So what am I looking for in my general formula, right? What am I looking for? So in a synthesis reaction, there's always going to be like a key telltale neon flashing sign that it is synthesis. On the left, you're going to have 2 or more elements. So the elements are just marked by, this is an element A, this is element B. On the right side of the arrow, you are looking for one single product, one compound on the right side of the arrow. This means when you're making a synthesis reaction, you're putting these 2 things together, you're forming a product, one product. So this ends up being your telltale sign, okay? For example, if I mix hydrogen with oxygen, I produce water. Water is one compound. I don't mean one molecule or one atom. I just mean one new substance. Another way of saying it is there's no plus signs on the right side. So if you're looking at a list of equations that are written out for you, you're going to look for, hey, on the right side, there's no plus signs. No plus signs right here indicates it's got to be synthesis. There's no other option. Okay? A decomposition reaction is the exact opposite. If you're decomposing something, right, there's a body in your backyard and he's decomposing, that means he's breaking down. All right, so that's what's happening in a decomposition reaction. You have one compound that's breaking down into 2 or more smaller things. It's breaking apart. So it's the exact opposite of synthesis. Instead of on the right side having one product, for decomposition, on the right side, you're going to be looking for one reactant, one compound, one type of substance that you're going to see on the right. It breaks down into its separate parts. Okay? What's another way of saying it? What's another neon flashing sign I'm looking for? No plus signs on the left. So this would be no plus signs on the left side. And then your synthesis is going to be no plus signs on the right side. Right? So that's those two types of reactions. The next 2 are called single and double. Now on your note sheet, on your module, in your book, you can see this word 3 different ways. I'm pretty sure on your end of course you're going to see it as the word substitution. So this could be single substitution, single displacement, single replacement. You might see it as all 3 things. This is the general formula that these guys follow. This is where you have plus signs on both sides. Notice your general formula. There's a plus sign on the left, plus sign on the right. What's happening in a single replacement is that this is always going to be a metal, right? Metals always come first. You're going to have a metal and a non-metal compound, an ionic compound, and then you're going to have a single metal by itself, alone, right? A single element alone. And what happens in this reaction is that the metal that's with this non-metal switches places. There's a single replacement. The metals actually switch places, right? Now the metal that was alone is with your non-metal, and then the other metal came off and he is now alone. So they just basically switch places. So what's my big neon flashing sign I'm looking for? I'm looking for a single element on both sides of the arrow. Look at my example I've given you. Here you have aluminum. He's alone. He's not combined with anything. Over on the right, you have hydrogen. He's alone. He's not combined with anything. Yes, I understand that there are two hydrogens here, but remember, hydrogen is a diatomic molecule. When he hangs out by himself, he bonds with another hydrogen and acts as a single unit. So here he is a single element, okay? And notice that in your compound, these two guys switch places. Or sorry, in your reaction, these guys switch places. And then these guys switch places, okay? So that's what you're looking for, a single element on each side, all right? Now let's look at double. Double, same thing. Substitution, displacement, replacement. All those words mean the same thing. Here, you're going to have two compounds on each side of the arrow. So you're going to see plus signs on both sides, right? Plus signs on both sides means it can't be synthesis and it can't be decomp. So if you've got a plus sign on both sides, you have to pick between single or double. The difference between double and single is the exact difference between the words single and double. In a single replacement, you have one thing switching places. In a double replacement reaction, you have to have two metals or two things switching places. So here you see that A is with B. On the right side, now you see A with D. So the A switches places with the C. That's what's happened. So two metals get displaced or get switched. And look at your example. I have a compound. I have a compound, I have a compound, I have a compound. And from here and here, these guys switch places. Hydrogen was with sulfate, magnesium was with nitrate, and now they've switched. Magnesium is with sulfate, hydrogen is now with nitrate. Okay? So those are the examples that you're looking at. I have the blanks in the front to show you that yes, it has not been balanced. Okay, I just wanted to be able to show you the different types of reactions. We're going to practice this in class and go over it together. And I'll make another video where I actually have a list of reactions or list of equations on my sheet. And I'll actually go through and help you highlight or pick out, hey, what's my neon flashing sign? What's the thing I'm looking for? Right? So those are the four major types of reaction. Another video will cover the last type.